We will be starting soon. So just give us a few minutes. We're setting up. We still have a few minutes left. So. Hey, Vlad. Let's make sure we can hear. And whoever is online, if you can just let us know. Hey, David, let me know if you can hear us. Vlad, can you speak something? Because I can't hear you.
Hello?
Yes. Hi, Vlad. I can hear you. Can you? Hi, Jonathan. Yes, if
Hello?
you guys can, just one of you let us know if you can hear us.
Okay. I can't hear you though. No.
You cannot hear me. I can hear you.
Okay, let me go back and check my audio.
Bit staticky, okay. How about now? Is it still? Okay. Yeah, let me know. Sometimes this phone interferes. So these guys can hear me, Vlad. So it might be your audio. Yeah, if you guys have any issues with audio, please do let me know. I'm not going to be the one who'll be talking most of the time. It's going to be Vlad. So we want to make sure. Oops. Cool, Jonathan. Thank you. Yeah, I
Hello?
think it might have been my iPhone sitting next to these things. Too many gadgets here. And seems like the video went away. It's kind of weird what's happening today. It always happens. Maybe something got messed up right here. We'll see. All right, bear with us, please, while we set this up. I'm gonna make sure video is coming through. I don't want to leave this feed. I've done this in past where I've left the feed and all of a sudden everything is just gone crazy from there. All right. Okay. All right. I think we're good. So Vlad, can you hear me? If not, just text me. It seems like your mic is on mute, Vlad.
Can you hear me?
Yes.
I can hear you.
Okay. Seems like everybody, and I'll just wait for a signal from somebody, Jonathan or David or whoever is there, can give us a thumbs up. All right. All right, I'm going to start. We have a few people. I think there is a game going on. We get a lot of people from India as well. and from around the world, actually. So there is a great cricket game going on right now, which I left. I didn't realize it's going to be so exciting. And it'll end in about maybe 15, 20 minutes. Maybe, yeah. So we might see a lot more people join, but all right, cool. So what I'm talking about today, I have a lot, as you guys have seen him here. So machine learning and predictive modeling is, the old new, not new particularly, but new to the digital marketing and analytics field. A lot of organizations are spending a lot of efforts to understand users' behavior and how can they predict the outcome based on the data they have collected, right? Going beyond what your tool providers such as email provider can collect or Google Analytics can collect, etc. There is tons of data sitting there. And I was talking to Vlad and was excited to have him teach a class on Python. And Python is a multi-purpose programming language that is used extensively for all sorts of programming. And then it has found its way, or not found its way, but it's now becoming the primary language, programming language to write predictive models, machine learning algorithms, etc. Right? There is also a competing language called R. However, what I've done my research when I started, and it was funny, like we were talking about, Vlad and I were talking about 2 days ago, is how R was the programming language of choice, but slowly it has become Python now. More and more companies are using Python. So I thought it'll be very appropriate to have Python class. Definitely, we might have R class later on, but I think Python, since it's used extensively to build these models, and it's easy to understand as well to write. So we'll have this class. Now, how you can use predictive models or algorithms to figure out what's going on is the use cases are several. Yeah, now Google Analytics is putting all its data in BigQuery, right? It's raw hit level data, which earlier wasn't possible to get, or was possible to get, but very difficult to set that up. Now it's all stream. You just set it up with few clicks and you have the data in BigQuery. Using that data, which is like you're looking at each individual event, user, their actions, all the categorization, you can create models that will help you predict how much revenue to expect, which marketing message is going to work, what actions drive people to go through the conversion, how many touch points it takes, etc. All those things. And companies have already been collecting data from their email marketing systems, and also collecting from CRM systems, tons of data being collected. So all that stuff can also come to life if you know how to write these algorithms. You can really wow your audience. And that's the whole intent, is because marketing is moving towards that direction. I want to make sure, like from Optizent Academy standpoint, it is critical for us to keep teaching these things, because I've been talking about learning SQL and learning some of these programming skill. If you want to be an analyst, if you want to be just an implementation guy, then there are implications here, because the data quality matters a lot. You have to have proper data quality, as Vlad will talk about. So I don't want to take too much of Vlad's time, because he is going to get into and talk about the use cases, and also how to write these things. He'll show you some examples. But keep in mind, the possibilities with this are endless. So it's how you think, how your brain is going to work. And that's what we want to show in these classes, as well as definitely there is a full class that's coming up, and which we'll talk about at the very end, where you can learn hands-on and write on your own data if you would like. So with that, I'm going to hand it over to Vlad. Take it over from there and teach us Python and how we can use it for marketing. Show us some examples. And I am going to also make you a host so that you can share everything. Once you are done, then switch it over to me. Yeah.
Great. Thanks, Anil. First, let's do an audio check. Can you hear me? Great. You can hear me. Great. So I assume that everything is is working as far as the technology. So first of all, again, thanks for inviting me to your YouTube channel. It's a pleasure to have this opportunity to speak. Okay. And let me start with, you know what I was planning to do today is to talk about predictive modeling and Python as our tool of choice for predictive modeling. Okay. So I'm going to show some, well, I'm going to have to rely on PowerPoint to structure my presentation, and I'll be showing some examples in Python code. So again, the goal is to not that much to teach Python, because for that we'll have a dedicated session, but this is to demonstrate its power on the one hand, and how it is accessible and democratic and could be learned by someone who is a quantitative professional on the other hand. Okay, so let me share my screen first. Okay, I'm going to share my screen, and I'll switch to, okay, so I hope it's visible, whatever I'm showing. I'm showing the themes for today's discussion. So the themes are predictive modeling on the one hand. So we'll discuss what predictive modeling can do for business and specifically for marketing. And on the other hand, we will talk about Python and how do we get started with Python, and more importantly, why do we want to get started with Python? Why don't we just, rely on our traditional tools? So Anil, if there is any technical problem that you detect on your end, please let me know. Or if there are any questions, I would also appreciate if you could kind of give me a heads up.
Yeah, I'll be watching the live chat stream here. So if you guys have any questions, please let me know. There is a bit of latency between when we show something and then when it shows up on YouTube. That's by design to get the best quality. So there will be some delay, but that's okay. I will be watching the stream. I'll let you know if there are any audio issues. Please do let us know. All right, you're good to go.
Thank you. Okay, so let's talk about predictive modeling. And again, Python is a tool. There are other tools. For some, whatever reason we decide to choose Python, we will discuss that a bit later. Let's talk about what predictive models are and what they do for us. You may have heard, those of you who, I should say, new to the area of data science and another area that is referred to as machine learning. Predictive models are based on real world data. And what they do, they are designed to predict the state of a certain system, the system that you are interested in, right? And the state of the system we call output for a specific scenario. And the scenario is going to be called input. So you know that we predict output from certain inputs, for which we have this mathematical / computational model, okay, that we are developing, again, based on a very relevant and specific data set. Okay. So why do we need that? Why are businesses kind of switching over to this predictive model mode of operation? Predictive models help making informed decisions, and by informed, I really mean decisions that are grounded in your enterprise data or other types of data. Okay. So predictive doesn't really mean that these models necessarily predict the future, right? Because you can predict, of course, you can forecast, you can predict what's going to happen, tomorrow or in a week. But more importantly and more generally, we want to be able to predict what our system is going to look like under such and such conditions. And my favorite example here may not be that relevant to marketing, but my favorite example that many people can relate to is, because it's such an interesting area of human activity, is autonomous vehicles or self-driving cars. So the self-driving car collects data about its environment and then makes a decision what to do next, right? So this is how predictive models work. And then if you translate the situation into a business situation, you will realize that, well, we are basically doing very similar things, right? We are trying to make a decision. And we really need to understand what would be the best decision based on our environment, our kind of circumstances we are in, and the scenario we are in. Okay, so machine learning is a couple of words that essentially you should keep in mind, because it's the modeling kind of framework that is in the back end of predictive modeling, right? Nothing else. We are not going to be talking about artificial intelligence here, but you hear the words machine learning a lot these days, and machine learning and predictive modeling in a kind of a business situation should be really understood as essentially similar kind of concepts. Okay. So why do we want predictive modeling? Why don't we just go ahead and do whatever we've been doing for hundreds of years? So the thing is that you may realize that decision making that is based on algorithms, right? So decision making based on algorithms, or as I call it, machine assisted decision making, in many cases is going to be better than intuitive and based on things like experience, common sense, and your kind of professional, should say, abilities, to make a decision. And the larger and larger your data sets become, the more and more difficult it's going to be to make a decision in a truly kind of data-driven manner, but without any help from the machine, just simply because very large data sets are very hard to analyze cognitively. And by cognitively, I mean the traditional approaches where you, let's say, create a dashboard or create a graphical representation of your data and then kind of make conclusions directly from what you are seeing, right? But again, as data sets become larger and larger, efficient visualization and efficient communication between yourself as an expert and the data becomes more and more difficult. So this is why we need the machine to help us assess the data. And another aspect here is that if you're using your intuition to make a decision, you may have your own kind of mental approach to making a decision, but it's going to be very hard to transfer your approach to someone else, right? If you want to teach someone else how to make decisions, it's not a it's not a very well-defined process, right? Because you are based on your own experiences, your own biases, and the person you are teaching to make decisions is going to be their own experiences and biases. So the process is not going to be very well reproducible. While if you have a machine code, then the process is by definition really well reproducible. So here, when I talk about system, right, we are predicting the state of the system, right? I mean, by system, I mean pretty much anything, like an engineering system, a business system, something that is domain specific, for example, an e-commerce problem or a banking problem, healthcare related problem, and so on. So anything that has the relevant set of data that describes the behavior in the system potentially could be used to build predictive models. Okay. So let me know if this doesn't make sense for anyone. So let me show you a couple of examples, and because I guess our discussion here very much pertains to marketing applications, I chose a couple of case studies that I found on Kaggle. You know, Kaggle is a community that basically works collectively on solving data analytics problems. Okay, so I found two data sets in Kaggle that I would like to discuss today. Again, this discussion is going to be pretty much superficial, basically mostly a demo rather than an in-depth solution to the problems, which would take, potentially could take a lot of time. Now, I'm showing my screen. I'm showing what we know as Jupyter Notebook, which is our sort of preferred method of using Python for data analytics, okay? So let me first talk about the data sets. And you don't need to, for this discussion, for the rest of this discussion today, you don't need to pay attention to the code at all, except please make a note how short and high level the code is. So we are achieving really impressive results by writing maybe a couple of lines of code, right? So this should be really viewed as an example of how high level and accessible Python is in its application to data analysis. Okay, so let's look at this data set. This data set is on Kaggle. It's called email campaign outcomes, or it's called something different, but this is how I prefer to call it because kind of it describes what this data set is about. So it looks at a set of emails sent out, right? And each email has a number of attributes listed here. So it's a type, and there is one that is interesting called subject hotness score, okay? Source type, location. I'm not really going to dig too deep into each of these parameters, right? For a number of reasons, right? First of all, they're not really very well described on Kaggle, and we can kind of pick up what they mean from their names, right? From their titles, for example, word count, total links, total images, and so on. So each email message has also a status assigned to it, and the status is labeled as 0, 1, and 2, and loosely this means that 0 is an email that was delivered to the recipient but no action was taken. 1 means that the email was delivered and was opened, and the 2 means that the email was delivered and opened and clicked on. Okay,
Yeah. Can I add something to this, Vlad?
absolutely, Anil.
Yeah. So in this, I've done tons of email analysis in past. Like this is one of the most productive channels. When you send in emails, you know the customer. So when you look at your email data, your email provider is just going to give you like email was sent to who, and then some information whether they opened email or not, or clicked on email or not. But you can actually go into the email that was sent and create a bunch of other attributes, as you're saying, like, word count. How many words were in that email? How many links did we set? Did we have an image in that or not? How many images were there, right? What kind of content was there? Was it action oriented? Was it informational? Was there a download in there? So it's as a data analyst, one of the key things is to prep the data. Having the right set of data is very critical. And that's where you guys need to start thinking about, okay, what data can I get from this information? Can I get other customer attributes, like not just the customer ID, but where is this customer, like customer's location, which actually is shown here, but maybe number of family members, lifetime value, all that stuff, or the online events they have done. They have downloaded a white paper, they have clicked on this button, etc. All those attributes will make your data very rich, and the richer data will actually help you predict what's the thing that's driving. So I just want to call these out. These are just some of the examples, and all these scores are given by internally in your data. I think the subject hotness score is something which might be a subjective score, which could actually be driven from another system. Saying how hot means, is it there is urgency or not, those kind of things. But you categorize your data and then put the data in this format. So, sorry to interrupt, but just I wanted to add that.
Absolutely, Anil. Thanks. I appreciate, because your kind of vision of the significance of these data sets is very important. So please share if you wish. Just feel free to interrupt me. If you need to add something like this. Thanks. So one thing about this data set is you will probably also notice that the output, right? The outcome, which is email status. So we have in this data set about 55,000 email that was delivered but not really acted upon. Only 11,000 were opened, and only 2,300 something were actually opened and clicked. Okay, so this is always, I think this is always the case in marketing, right? So very small fraction of your effort actually brings value to your organization or to your project. Okay,
so that shouldn't be the case, right? So we need to improve that. That's the whole point, right?
Exactly. So this leads me to the first motivation, which is probably most important motivation for predictive modeling. Wouldn't you love to be able to predict these settings right? Such that it yields the best possible outcome, okay? So the model that you're developing will allow you to map your email, and you will be able to design your email such that it will at least increase the probability of favorable outcomes, such as the email was opened and clicked, right? And you want to drop the cases where email was just sent without any follow-up, okay? So, and let me look at another example that is also more or less related to marketing work. And this example is called telecom churn dataset. So this dataset, and again, Anil, please jump in if you want to add to the description of the use case. So this dataset describes customers of a certain telecommunication company, I guess providing cell phone and internet services. And it describes the customers using, this big set of attributes such as a gender, whether it's a senior citizen or not, whether they have a partner, dependents, how long they have been with this company, and so on. So there are many, many attributes. Okay.
Yeah. So, yeah, I want to add something again to this one is similar analysis. I'll give you an example on how this was done for taking online and offline data. This is your CRM data, right? It's sitting there. We know who the customers are and what have they used, etc. Similar stuff we did for like a wine subscription service where they were having this problem of people canceling their subscription. That's churn, right? People not going to renew it or not going to buy from you is how you'll say they're churning, right? So for that, we needed to find out what's the driver and how can we find out that who's going to churn. And that's exactly the kind of thing you can do. If you have this data, again, you can merge online, offline data, the data points that come into play, then you can find out what's their what kind of action is going to predict that if they're going to buy or not. In this, when you provide this data, it might give you, hey, senior citizens are likely to churn, or people who have dependents are likely to churn, whatever those attributes are. In that scenario, what we found is actually there were no predictors in this type of data. The predictors were actually online, and the actions they were taking online. So if you think about this, Google Analytics, you're tracking page views or events. Now in the new model, very event-based, what events they are doing, or what are the attributes of those parameters of those events that can predict. So bring that in. So what we found is people who are checking X number of times in their My account right a month before their subscription was about to end were likely to churn. Those kind of things we found out. And once you run the data, because you have thousands and thousands of records, maybe millions of records, and it's hard to just eyeball and find out from your data visualization. That's why you need a system like this.
Yeah, thanks, Anil. This is really valuable. And actually, the point you are making is that we are not even sure in this case whether we are logging the right type of data, right? So the data we are logging may or may not lead to a meaningful prediction. And then the process becomes really iterative, right? Where we are trying to tune up our predictive model.
Right attributes, right set of data.
Correct.
And again, I think this is what I want to call out every time, which is the data quality is the number one thing that you need to pay attention to. What data are you collecting, how you're collecting, and is the quality there? If you get bad quality of data, you haven't put the proper attributes, or you have misnamed them, or there's no proper nomenclature, you'll have a very hard time coming up with these things. So once you set that up, then you come and you can find lots of things with Python.
Yeah, and we are talking about data quality in a very broad sense, not just the fact that our data contain incorrect measurements, errors, or missing data, but whether even the entire data column has any meaning, right?
Yeah,
or
exactly.
whether we are maybe missing something important. Again, this is going to be discovered in the course of developing the predictive model. So, but let me not jump ahead. So here in this case, again, churn, which indicates whether or not a customer cancels a subscription, is going to be our output right? Which our outcome, which we are going to have to model against all these attributes. And then hopefully we'll have a good model which will allow us to predict which segment of customers is more likely to stay with us, and then put all our effort and everything else towards these specific customers, and not to waste money and effort on the customers that are very likely to drop out anyway. Okay, so this is probably the biggest motivation so far for predictive modeling. Okay, so predict something valuable. Predict means system response, not necessarily future, but something that brings actual value to our organization, our company, and so on. And the next one that Anil already gave you a preview is understand the drivers. Those two actually go together. So which one of these, okay, which one of these attributes are most important for customer retention, right? Similarly, in the other data set, the question is going to be which one of these attributes is most important in designing your email, such as is going to generate some action. Okay, so this is the next motivating factor. The third one is, I call it reduce uncertainty. And this is something that is not going to be achieved, in one click immediately. Reduce uncertainty means that you are kind of moving towards more and more precise and high granularity types of data that you want to log. You'll be discovering that some of your data is not necessarily going to need to be logged because it's not really very meaningful, but maybe you are missing some data columns, right? Maybe you need to dig deeper and start collecting and logging data that you may need, right, in order to design a very good predicting system, right? Okay, and also you are going to be able to understand patterns in your data, which leads to various interesting discoveries, right? This here I'm referring more to exploratory work and something that is more like research, but this is equally important because, again, understanding patterns in your data will help you understand the system that you are working with. And this activity could be more long-term, okay? But still, I mean, it can still yield very interesting results, okay? And finally, experimenting, right? If you want to study your system, and by system, again, I mean, these two cases mean either your system that generates emails, right? Or your organization that is suffering from customer churn, right? So running experiments is not very practical. I mean, in the scientific lab, the situation is very different where we are paid to run experiments. But in real business, experiments are expensive and time consuming, okay? So if you have a good model that tells you immediately what would be the outcome of your experiment, then you don't need to run the experiment. You just, run a prediction or a model, which is done in a couple clicks in your whatever software or tool you are using for predictive modeling. So I already showed some Python development environment and some code, okay? So now let's talk about why would we benefit from learning the basics of Python. And this is a set of points that Anil and I developed some time ago recently that demonstrates kind of all the view from different angles on why Python, why not other tools. So Python actually, first of all, it is great for data manipulation. Python is initially was designed as a general programming language, which is not that useful specifically for data analysts, data analytics. You need to be a software developer, you need to be a programmer to write something useful in Python. But more recently, it has become really a language of choice for data analysis because it has many libraries and where you can actually program at a sufficiently high level. So you don't really need to go into the depths of programming. You can just write one line of code and you'll get a linear regression model. Then you write another line of code and you test your model. Okay, so this is how you can do it. This is why if you look at the code that I just shared, generally it looks like there is very little code. There is mostly interesting outputs that we would want to discuss as data analysts, okay? So that now, as a language, also Python is kind of intuitive and it is easier to get started if you compare it to other popular programming languages such as C++ or even Java. So Python speaks English. That's how I put it. Okay. And the next point is, as an analytics tool, Python is open source, and that means that first of all, development in Python is free. Now, storage and computation is something that is free only if you own the computer, but development part is always free, right? You don't need a license. Unlike other tools that could be very expensive, I'm not going to name them, but hopefully you know what I'm talking about. Okay, so as a result of being open source, also Python has a very high degree of flexibility, and it's easy to scale up, and it's easy to connect to big data tools. So in the case if your data set becomes so huge that it's not going to fit on your desktop computer, then you will need to kind of look into big data tools, and then those tools are also programmable in Python. Okay, and finally, as a bonus, you get to use Python also as a general purpose programming language, which will allow you to automate various tasks in your analysis, okay, especially the repetitive tasks that you don't want to perform manually. Okay, so these are the drivers, motivators for learning Python basics, okay? So to get started, first, you need to learn Python essentials for data analytics, okay? And again, the point here is, right, the keyword here is it's Python for data analysis, not Python as a general programming language. So you will see differences here, right? You don't need to become a software engineer, okay? This is not the goal. The goal is to be comfortable with the environment and then start learning the data analysis libraries in Python, right? That will allow you to manipulate and explore your data and develop predictive models, and actually even deploy the predictive models for your organization to be used to generate value. Okay. So as you learn Python essentials, you will realize that the prototype level analytics tasks can be accomplished at a very high level in terms of writing, the amount of code you need to write. So it's going to be, as I said, one line of code can actually create a predictive model in Python, and the library I'm referring to specifically is called scikit-learn. Okay, so you need to learn about several really important libraries or packages that would contain all the functions that you need to conduct data analysis. Okay, sorry, 1 second. Okay, and now to get started with the practicality of getting started with Python, it is free, so you can download it and install on your desktop. That's one option. Another option is to use Python in the cloud. Okay. So in the cloud means that you can access a development environment just through your web browser, and the tools that I would mention here are either Google Collaboratory, that is very useful and highly accessible tool. It is free, and Google gives you computation for free as well. And of course, storage, because you can link it to your Google Drive. And another example for using Python in the cloud will be Kaggle kernels. So Kaggle is, again, it's a website, kaggle.com, and also it's a community for data analysts, for data scientists, and machine learning engineers. So they work collectively on solving various interesting problems.
Vlad,
Yep. Yes.
Somebody who's listening and wants to start learning on their own, right? So will you be talking about like where to go in Kaggle or all that stuff, like just like basic steps so they can get started on their own?
So to start on your own, if you would like to go to Google Colab, I think it's a good place to get started. So this way you can get used to, for example, to this type of development environment, which we call notebooks. Let me go back to my code. sorry, get used to this environment called notebooks. Okay, Google Colab actually also uses notebooks, and notebooks are designed such that you can type a bit of your code in the code cell and then interactively sort of execute the code and then see the output immediately. Okay, so this is a good place to start if you would like to learn it on your own. Again, because again, you have access to the environment where you can write, kind of test and execute your Python
So
code.
Google Colab.
Colab or collaboratory.
Okay.
Yeah.
Cool.
Okay, so meanwhile, let's see what we can do with the data and how would our process work with and without the use of predictive modeling. So as analysts, what we would typically do, we would try to describe our data using either visual representation or some kind of a parameter set, as we do in descriptive statistics, and then kind of infer from this knowledge. We can infer, basically, we can infer something about the variable of interest. So, for example, for the telco churn example, we can make these two box plots. And this is an example. This is not a guided solution to the problem, right? Just an example of what you would do without predictive modeling. So for example, we are plotting churn as a function of customer tenure. So what we are going to realize from this plot is that mostly short-term customers, short tenure customers tend to cancel their plans, and long-term customers tend to stay. Okay, so this is kind of an important finding, right? It may sound obvious to those of you who are intimately involved in these types of problems, but this is what data is telling me. Okay, so that, for example, I can make a decision such that long tenure customers are my favorite kind of a group of customers into which I'm going to invest a lot of funds and activities, and then short-term customers, they have to prove that they are to stay. Okay, so that's why not? I mean, this is a valid valid reasoning.
Yeah, I mean, I think this actually tells you, which is kind of intuitive, but there is a threshold that you will find. We have to move customers past that. So acquiring new customers is difficult for any business, right? It takes a lot of money. But also you're seeing is if customers don't stick around for, people have a higher churn when they're early on. Once they go into the longer term, they become longer term customers, they are going to less likely to churn. So your marketing tactics or your promotional activities or tactics or the way you engage them might be different. Hey, this is a new customer. We need to nurture them really, really well because they are very likely to churn. And we might do certain things differently than long-term customers. So that all, that data informs your strategy of customer engagement, marketing, even when somebody gets a customer support call and they know like, hey, is this customer newly acquired or within this period of time, what do they need to do specifically for those customers compared to people who have been in the system for quite some time. So
yeah,
something that informs your business decision making.
Oh, okay, so that makes sense. And what I'm going to kind of challenge though here is the granularity of this evidence that would support our decisions in very holistic manner. Of course, this is something that is easy to discover from the data, just visually, and maybe with some statistical tests on how significant this dependency is, you may be able to make a choice of how you would approach the churn problem. Another observation, by the way, is when you look at the monthly charges, you will also realize that customers that pay more per month are more likely to drop out, right? This is what this graph tells me, right? So churn equals yes for the customers that have higher, in sort of average, higher monthly charges. Now, this is, if you won't just disregard these customers, they actually bring a lot of revenue to us, right? Because they are paying high monthly charges. So we don't want to just, disregard them as those who are likely to drop out, right? So this is, there are uh, granularity problems if you use, this type of analysis. Okay, so there is more.
So,
Go ahead.
Vlad, I just also want to call out here. So what you're seeing here is this is the only line of code that's required, right? For
Yeah,
that data, once you
yeah.
load it?
The line of code, yeah. For plotting this type of a plot, I just use basically the box plot function in Python and then specify what I want to plot. Look, by the way, yeah,
Yeah.
thanks,
So I
Anil,
think
for
that's that.
yeah. See how
Yeah, I just
intuitive
want to make
this.
sure, like, there is a tangible value coming out for people and saying, hey, I want to create this. Can I do that?
Mhm.
And again, I keep going back to because a lot of audience here are used to dealing with Google Analytics data as well, or the
Yeah.
web analytics data, not just CRM and email data. Some of them might be,
Mhm.
but similar stuff. If you know your event data is actually being now sent to BigQuery or in a format that you can actually create a flat file,
Mhm.
follow these steps right here, what he's showing, and then you can start to create those plots. Now, a data element by itself or the attribute by itself is not enough. You need to have the full view. Because if you just say monthly charges are higher, then people are likely to churn.
Mhm.
Maybe there are other factors that are affecting too, right? So,
Oh yeah. That's a
yeah.
great point you're mentioning here, and again, visual analytics. We are confounded into this two-dimensional computer monitor or paper, and our data set has how many dimensions? Let's go back to it. Our data set here
So,
has many
one
variables.
question. Yeah,
Yeah,
Vlad, one question came up from Jonathan. Are
yeah.
there algorithms already for churn as an input? Um, I'll let Vlad answer, but I
Mhm.
think my view is there are not algorithms. All what he's showing is you have a set of data that has outcomes. So you got a set from past customer data. You have a set which says, which customers are going to churn and which ones aren't,
Mhm.
based on all these attributes. So you train your model based on that. So I think maybe he's asking about are there
Mhm.
predefined models that he can use? That's the one he's
Oh, okay.
asking.
If
But once you train that, and
Yeah, so
yeah,
if the question is how
go
this,
ahead. I'll let you answer
absolutely.
it.
So if the question is, I guess, how this line of code works, uh, the names for churn and monthly charges are coming from the names of our columns in our data set. So we are referring.
No, I think he is asking, and I'll let him clarify. Basically, what he's asking is, are there predefined
Mhm.
algorithms that he can use and feed the data to get this
Oh,
level of
okay.
insight?
I see what the question is about. So,
Yeah.
first of all, the answer is I'm not sure. Maybe there are. The point I was going to make here then is that you may not want to use existing algorithms because unless you are 100% sure that they are relevant to your work. And why I'm saying this, algorithms could be built based on historical data. Okay, algorithms could be
Yeah.
built on.
Your customers are
Yeah.
different, right? Every customer or the audience set is different. The way your company
Mhm.
operates, the business they do. So there will be different attributes available for you. There will be different weightage given to those attributes. So you have to kind of play with your own
Mhm.
data. And what Vlad is going to show, actually, once you learn Python, it will become easier for you to say, okay, this is how I can do
Yeah.
this
Actually, I
stuff,
just wanted to add a
right?
couple because I like the question from Jonathan about existing algorithms. The thing is, in this, generally, when you're solving business problems, it's very hard to rely on a theory or on something that is built, uh, as a general model because it's very hard to generalize. And I really think that we should go the predictive modeling way because predictive model gives you the story in your data, something that is a pre-existing or existing algorithms or something that looks like a theory or first principles. uh, I wouldn't trust that as a source of my predictions, again for the reasons that it's hard to generalize things in business, right? But on the other hand, your data has everything that you may need to make a decision. Okay.
So the volume became low for me. I don't know if it's for everybody or not, unless you change something on your end.
So I
But
did not, but maybe it's a networking thing. How
okay,
about now? How about now?
yeah, that's fine.
Okay, good.
And
Okay, so
hey, Jonathan, if something is it still needs to be answered, we can connect after this session. I have a meeting right after this session, so I want to end it at on time, which is we have about 12-13 minutes left.
yeah, absolutely. So I just wanted to show you, okay, so now I've been kind of preparing the audience to what predictive model actually does and showing what is maybe not the right approach or maybe not the most granular approach to predictions. So we are going to learn about or talk about classification. And classification is the way of predicting generally speaking, something that is a categorical variable. For example, in our churn model, in our churn data set, this categorical variable is the outcome, the churn, which could be either yes or no. Okay, so we use classifiers for that. And let me show you maybe using this kind of example. This looks a little bit convoluted, but I am plotting here in this. Can you see this plot? I'm plotting here two variables. And the color coding corresponds to whether this customer is churned or not. And we are going to choose we are going to compute the conditions for these two variables that would tell us whether the customer is or not likely to cancel their subscription. So what we need to do in this case, okay, and this is, again, this could be new for some of you, or it could be intuitive enough to understand or not. So when we look at, let's say we have only two variables, because this is all I can plot in 2 dimensions. We have only two variables. We need to develop our classification model in the form of what we call decision boundary. So in this case, our not churned customers are color coded as blue, and the churned customers are orange. So we need to find the condition that separates blue from orange. Okay? So I'm kind of trying to explain this in a kind of a graphical manner, which might be better to understand. So we are trying to mathematically define a condition that would separate yes from no. And real world data is usually not very intuitive and clean. So my kind of other illustration of this problem, if you look back into my slide deck, so I have illustration of these two class problems, and we need to find the decision boundary. If these classes are well separated, okay, so if there is a set of variables that gives you not churned customers and another set of variables that gives you a churned customers, then in this case it will be easy to define the decision boundary, right? So it means that these two variables will give you customer retention if their values are above this red line. If they're below the red line, they will give you, customer cancellations. But again, in real life, your data will look something like this. And to develop this prediction, right, in the form of this decision boundary, you will need to go into certain types of algorithms. And these algorithms are known to be, for example, logistic regression or decision trees algorithms. And you will need to generate your predictive model that would be the best in terms of its prediction error, right? So in this case, we are saying that anywhere in this area, our prediction is non-churned customers or blue class. And in this area, we are going to predict churn or orange class. Now, these data points that are blue, but they are sitting in our orange class, these are misclassifications or errors of classification. So any real life model will not be perfect. It will never have an accuracy of 100%. And the reason why not is, we can speculate about that maybe sometime offline, but there are lots of reasons why your data is not really giving you the perfect model. Most likely it's going to be imperfect, and you will need to optimize the model such that it gives you the best possible prediction. So this process we refer to as model selection. Okay. Let me know if this makes sense. Okay, so what I'm doing here is I'm applying first of all, I need to transform my data. By the way, yeah, this is very important. I'm going to need to transform my data set into a numerical form. Okay. So I need to carry out a lot of transformations, and the process is known as feature engineering. So my data columns become features. Feature is a variable that is fed into a predictive model. Okay. So I'm not going to walk you through the process. It's a little bit both complex and could be boring for this discussion, but you can see that from this raw data where I have most of my inputs non-numerical, it's either yes or no or some kind of a descriptor, I transfer them into a numerical data set, okay? And I create features from my variables. And then I'm going to run a model called random forest classifier. So random forest classifier is, again, I'm not going to deep dive into what it does, but it helps you decide from your data whether your customer is going to be churned or not churned. And another useful thing that you can do here, you can actually rank your variables by importance. This, again, this is a very generically, this is a very important outcome of predictive modeling. So here I'm going to rank, and Python does this for me, right? Again, as you can see, it does it for me in one line of code or 2 lines of code. I'm going to rank my variables by how important they are for churn. So I can find out that tenure is probably the most important one. Okay, so this column is some kind of a numerical score for variable importance. Then whether this customer receives technical support or not is important. And then it's followed by online security solutions. Okay, and so on. So this also, separately from predicting churn, this also gives you a lot of insight, okay, as a side outcome, maybe not that much side outcome of your predictive modeling. It gives you a lot of insight into your system. Okay, any questions or comments on this? Again, because this again is important.
Yeah, I think a question came from Jonathan. He's like, okay, this makes sense, just not sure how to start in Colab. So maybe we can take it offline. I think that also something that we covered in the 5-day challenge, right? How to start.
That's correct. Yeah, by the way, that's a good source. Will be a good source for you to get
I'll
started.
drop a link for that. So there is a 5-day challenge we did twice now, where people can go through, and by only spending like 10-20 minutes a day, in 5 days, you can get up and running with something like this on your own, right?
Yeah. Yeah, that one actually can get you started with Python quite a bit, not just Colab, but also
so I'll
other
send a
tools.
link out to that, as well as the complete class that's coming up. Like if you want to get hands-on with Vlad, then he can show everything and walk you through. All right. I'll let you continue, Vlad.
Yeah. Finally, let me know how we are doing with time. So we have a couple more minutes. I just wanted to finish off this process.
We have about 6 more minutes. So
great. So let me spend a couple minutes to finish off the discussion on predictions, and then maybe we have more questions and can address them as well. So finally, we developed a predictive model. We can start using it. One thing, we need to understand how good our model is. And for classification models, and I believe in marketing, we really need to focus on classifiers, right? Because our outputs are mostly categorical, such as yes or no, or in the email example, what the status of the email, which is 0, 1, or 2, okay? So to evaluate the model, we actually have a very much quantifiable set of tools for evaluation. So there is an accuracy score, one of them, right? So accuracy score tells you how accurate your prediction is. So in our case, our accuracy score is about 80%. Now, before you say this is not good enough, we have to really understand if we need very high accuracy, right? Because we can spend a lot of time developing a high accuracy model. We can also use the process for other purposes to understand our system, right? Understand the patterns and the drivers. Now, in some industries, such as airlines, 80% accuracy is definitely not going to be enough. Now, I'm going to claim that in marketing, sometimes we can actually bootstrap and just, use whatever we have, right? So if you have 80% probability that your prediction is correct, it may already give you a lot of value. So most likely, like 4 out of 5, you'll be making the right prediction, which is compared to 50-50 kind of guess, it's a big lift, right, in your predictive abilities. Now, another thing is that we didn't really spend a lot of time developing a very good predictive model here, right? We can always refine our model and make it better. Now, if your accuracy is hitting the limit, what is going to happen here is that probably your data is not very granular. So you might be missing some important variables that contribute into the low accuracy, right? Because you don't really understand your system very well. So this again allows you to go back and maybe check if we are missing any variables. So there are techniques, by the way, in predictive modeling that allow you to discover missing variables. Again, those are pretty advanced. This is not for today's discussion, but just to let you know, that it's not always just, the expert decision what variables are missing. You can actually use mathematical or more like probabilistic process that will allow you to formally discover hidden variables, okay? So anyway, here we have accuracy, and also another score for model quality is called confusion matrix. The confusion matrix tells you that out of the total number of cases, some of them are truly positive, right? As indicated by your data. And when you predict a positive on what is truly positive, this is called true positive, right? And if something is negative, then your output is called true negative. Now, if your true value of your variable is positive, but you predict it as a negative, then it is misclassification. And same goes by the case for the case when your value of your variable is negative, but you predict positive, or in this case, if it is 0, but you predict 1, or if it's no, but you predict yes, that's another misclassification, okay? So this confusion matrix tells you basically in the tabular form, tells you of how many misclassifications your model is going to produce compared to correct predictions. So again, in this case, you can see that the model is not doing very well, right? So it predicts churned customers out of the total of whatever it is, 225 plus 215, it predicts only less than half, okay? Whether it is good enough, okay, there is no criteria on whether it is good enough or not. It is really up to you as an expert to make a call whether this is good enough. If not, we work on refining our model further. If it doesn't work, then we work on refining our data set, okay? And maybe we need to make a revision of what data is important for us to log and store, okay? Anyway, so this is just a brief demo of what Python data analytics libraries can do for us. Again, please look at this from the perspective of how, I shouldn't say easy, but how high level programming is for data analytics, right? Very few lines of code give you very valuable outputs, okay?
Yep. Cool.
Yep.
So there is another question from David, not sure how to understand this metrics, but we can take that offline. I'll be happy to have another quick 15, 30 minutes or whatever session we need with Vlad for you to get better understanding of what you can learn in the class and how you can understand those things. So if you have any questions, feel free to send those to me and you can just send them as a message here, comment here, or those who have my email address, they can send it over there as well. So I'll connect with Vlad on that.
Yeah, brief answer
And
to
we can
David.
set
If we have just a few seconds, David, if you check the
Wikipedia, go for it.
I shouldn't be doing this, but if you check with the Wikipedia article for confusion matrix, it has a pretty comprehensive description of what it does. Okay, thank you.
Cool. Yeah, thank you very much, guys. I have to run to another meeting, so that's why I'm rushing up. Great. Otherwise, I let it go for 90 minutes, 2 hours, whatever is required. Make sure if you like the video, give it a thumbs up. Make sure to subscribe to the channel. We will continue to do more trainings. And there is a full class. I have dropped a link to that class. You will, for a limited time, you'll get 50% off on that class. If you sign up this week, then you can sign up for that class. It's coming up in November 2nd week, where Vlad will go hands-on and teach you everything. It's a 4-hour online class.
It's November 11th,
And
correct.
if you, yeah, and if you don't want to, want to sign up for that class yet because you're not sure, there is a 5-day challenge that I will also drop a link after the session and by end of day today or before that, which you can sign up. David took that class and he said it was really useful. So, that class will actually help you get started and see if this is something you really want to invest. And if you do invest, like I said, many companies are using Python. You will be all set, whether it's as a freelancer or whether as a full-time employee. Another video that Vlad and I did were like reasons for you to learn Python. And I'll drop a link for that as well. But now I have to drop off. You can leave a comment. We'll get back to you.
Great.
Thank you very much, Vlad.
Thank you, Anil, for hosting, everyone else for questions and listening.
Yes. All right. Thank you, guys. Make sure to give it a thumbs up to this video and like the channel as well. We'll see you and talk to you soon.
Great.
And there's more training coming up. So I will be sending emails to those who have signed up to be notified. You'll get more trainings on other tools, technologies as well. All right. Bye.
Bye.